Hey everyone, hope you're doing well. Today we're going to be solving between two sets. Let's get to it. So, a word of forewarning, this challenge is actually, I wouldn't necessarily call it difficult, but it's very difficult to understand. Or maybe it's not that difficult, but it's more so written in a very in a somewhat confusing way. I, speaking frankly, I felt as if I was dyslexic for the whole day yesterday reading this, and it took me to the next day. It's tomorrow morning, and I've solved it. But regardless of how weird this challenge is, I think it's a good way of really zoning in on identifying what needs to be done. Because we'll notice what when we read this problem statement. But you have to really clarify what each part, what each condition is, and how to find that condition. So let's try and understand the problem statement. So basically, we are given two integer arrays, right? And we want to return a certain number. Right? So we're given two int arrays. We want to determine some conditions. So the first condition is elements in array 1 are factors of the integer being considered. Let's call this x. Now, the second condition, the integer being considered. So x is a factor. Oh wait. Yeah. X is a factor of all elements in the second array. So it's already getting a little bit confusing right now, but it's one is just the inverse of the other kind of. So x is a factor of all of array 2. And up here, the first condition, array 1, this array 1, are all factors of x. Okay. So the easiest way that I think we can solve this challenge, or the most straightforward way, is to find x first. And then once we find x, we can element in array 1 find elements in array 1 that are factors of x. That's the easiest way of going about it, in my opinion. And obviously with each step, there's more steps involved, but overall it's actually not a bad general process. So how would we find x? So let's create some space here. Find x. So the way I would go about finding x is we want to loop for this second int array, for the size of this int array. So loop the size of the second array. What else? X. Okay. And then what we're gonna want to do is loop for the size of second array at the position of the element. Loop for the size of the second array at the element. Now let's say this again. Loop for the element. Loop for the size of the element, basically. So if the element is 5, it will loop 5 times. Okay. Now, why are we doing that? Well, what we effectively want to do is find whatever x is, which is it's a shared factor. It's a common factor between all the elements in the array. So what we want to do is find the common factors first. So find common factors first. Then what we want to do here is find just a factor. So if second array at position I, is it that? Oh yeah. No, hold on. X is a factor of all elements in the second array. Oh, okay, yeah. Times this by, I think it's times second array at position J. Is this correct? So X is a factor. X is a factor. So if X is a factor, so let's say the second array is, let's just commit a little bit of example. 5, 10, 15, right? X is a factor of 10, right? So the factors of 10 are 1 by 10, 2 by 5, you can't have 3, you can't have 4, and then you have 5 and 10 again. That's just simple as that, so you only have 4 factors here. So what we're doing here is actually what we can do is mod it and then equal to 0. So for example, we get 10 here. 10 mod 1 is equal to 0. Yes, so we know it's a factor. 10 mod 2, is that equal to 0? Yes, so we know it's a factor. 10 mod 3 is equal to 0. No, so we know that it's not a factor. Okay, so we don't push it. So we could splice the array, but the problem with splicing here is that we're using length of the array here. So if we splice the array, we are effectively changing the length of the array mid-loop. And yeah, it just gets a little bit fuzzy there, a little bit weird. I was actually getting length undefined. So I think it's better. I think it's always easier, instead of splicing, to always push to a new array. So what we can do is just define a new array here, and then just do common factors dot push second array. Oh, actually, is it second array J, or do we want to push J? I think we want to push J. Because then that'll will return 1, 2, 3, 1, 2, 5, and then 10. We don't actually want the number. Right, and then yeah, that's all fine. So this just finds all the factors, So find all factors. Now we want to, because we have all the factors, not all of them are going to be common, right? So we want to remove uncommon factors here. So how do we know how many factors there should be? Well, how many common factors there should be? Well, we know that for each common factor, a common factor should occur 3 times here, because there's 3 numbers in the second array. 1, 2, 3. Right? So if a factor is common, then it has to occur 3 times. So for example, 1 occurs 3 times. 5 occurs 3 times. 10 occurs twice. So 10 is not a factor. 3 occurs once, so it's not a factor. 2 occurs once. Yeah, I think that's it, just off the top of my head. So we know that we want to if a factor is common, it will occur 3 times. So what we can do is let's do. Actually, no. Let's call this factors here. Let factors. And then let common factors. There we go. That's a little bit more accurate. We want to do it for the size of factors. So for size of common factors. No, of factors. Factors array. And then we want to do the same thing, loop for size of factors array. Now the reason we're doing it twice here is because what we want to do is compare all the values with each other. So we want to compare this value, the first element to the second element, and then the first element to the third element, and so forth. Right? And every time the element is the same, we know there is a common factor between at least some of the elements. Right? So what we're going to need to do is implement a counting system. So I think we can do it. Yeah, let count equals 0. And then here, if factors array at position I is equal to factors array at position J, count ++. and then at the end of the first, I don't think it really matters where you do it, because it will only pass it will only pass when the count is of that size. But I think it's better to just do it at the end of this first for loop. Oops. It will run less time. It will run less times. Because up here, it's gonna run an unnecessary amount of times. I think we don't want to run it for every single one. We only want to run it for every one of these, I think. Well, not every one of these, but when at the end, when just before we change the number, is when we want to check, I think. So if count is equal to array 2 dot, second array dot length. So again, we said that here, second array, so it needs to equal 3 times. It has to be a factor has to occur 3 times for it to be common. So then here, what is it? Common factors dot push. We want to push the factors array at position I. There we go. Sweet. So now what we have is an array of common factors. Now there is a small problem here. Right. So these are the factors of 10. So if we try to find the factors of 5, it's simply just this. If we try to find the factors of 15, it's going to be 1 by 15, not 2, 3 by 5, and then I think that's it. Yeah. There's a problem here. If we keep pushing these elements into the array, so for example, 1 occurs once, twice, 3 times. So we push 1, or actually no, we push 1 and then we push 5. Then we push 1 and then we push 5, and then we push 1 and then we push 5 again. This is what our array is going to look like. Now there's all these duplicates here, which we don't really care for. What we would want, well, actually let me do it like this. What we want is this. Right? There is something called a set. I don't know if it's a function. Let's have a look over it. Set object. It's an object. Does it belong to a class? Standard built-in objects. What's this? Includes their methods and properties. Interesting. So it seems like it's something which is built in, and we can use its methods. So we can use set to store unique values. Set objects are collections of values. Or we create a set object. You can iterate through an element of a set in insertion of a value in the set may only occur once. Examples. Okay, yep, exactly. This is exactly what we want now. Right. So we want to remove duplicate elements from our array. So what we can do here is remove duplicate. Let unique factors equal what is it? It is okay. So we use our spread operator. We create a new set and we pass in the array. So our array is common factor. Right. So now we should have something that looks like this. Cool. So this is the first half of the problem. We have two potentials of what x is up here. Now the second thing that we can do, that we need to do is find elements that are factors of x, right? So instead of finding factors of x, we want to find what x is a factor of. It's a very, very fiddly thing to understand, but put simply, let's say x is 5, for example. So find elements that are factors of x, so 5. Now let's assume the first array is right. So is 1 a factor of x? Is 1 a factor of 5? I don't know. Let's do 5 mod 1. Now, let's just for simplicity call this divide. So 5 divided by 1. What does that equal? Well, it equals 5 because 1 goes into 5 times, right? But the remainder is 0. It fits in perfectly. 1 fits into 5 perfectly. So we know that 1 is a factor. Now let's try 2. Oh, sorry, 3. 3 is the element. What does this? What's 5 divided by 3? That is 1 point. What is that? 1.66, I think. 66 occurring. Because there's a third that's always not missing here. That's always not going in. So in reality, it's 1 remainder 1, or it's a third remaining over. Because when you add the 3 to the, when you take 3 from the 5, so 5 minus 3 is what, 2. You can still take 2. You can still take 3 from the 2, but you're left with -1, right? And that's a third that's left over, because the other 2/3 fit perfectly. It's just that 1/3. So we know that the remainder here is 0. Sorry, it's not 0. It's not 0. So we do not include this as a factor or a common factor. And then we check 2, and we also know that's not a factor. So the only factor in here that's common with all the elements of x, so the only factor here that's common with x is 1. So the operator we can use is mod to find the remainder. If the remainder is 0, then we know that it's a factor. So find factors. Check if element in first array. There we go. So the way I would do this is loop for elements in unique array. And then again, loop for elements in first array. And then, I think we're also going to want another count. So let count equal to 0. And then what we do here is we do that mod, that division scenario. We check that division operation and check to see if the remainder is 0. So if what is it? Unique array position I mod first array at position j is equal to 0, count plus plus. Easy, right? And then at the end, if count is equal to first array dot length, then here shared factors, what I want, shared factors dot push unique array at position I. I think that's it. Oh, this is a function, not an array. Right. And the only thing that I'm missing up here is declaring shared factors. So now, given this example up here, the only factor that should be in here, shared factors, should be 1. Right. Now remember, if we go back to the problem statement, we want to determine how many factors exist, how many common factors exist, not what the factors are themselves, but the common factors. Right. So all we do is return this. Seems fairly simple, or not. Okay, no, it's not fairly simple at all. But our solution is rather straightforward. We're doing quite a few loops within loops, but I think it works. Let's give it a shot. As for edge cases, well, let's see. The constraints are there is x and there are different occurring numbers of values. So the first array might have a different number of elements to the second array. We don't know. It doesn't say they're equal to each other. So we're sorting through them dynamically anyway. Here, for the size of I and j, we don't know if they're equal. They could be anything between 1 and 100 inclusive. Are we dealing with that? I think we are. Yes. So we're looping for the size of the element. We're not assuming the element size here. So if the element is 1, it will only loop once. If the element is 100, we'll loop 100 times and we'll look at the values 1, 2, 3, 4, 98, 99, 100 and check to see if all those values, which values are factors. Right. So I think we're ready to give this a shot. So what is the first thing that we have to do? find all factors. Right. So let factors just an empty array so far. What's next? Loop for the second array, and then loop for the element. So for let I is equal to 0, while I is less than a, no, same array. B dot length, I plus plus, and then here, for let I equal 1 here. I'll explain why in a second. Sorry, not I, J. 1, while J is less than B at position I, J plus plus. Okay. So why are we doing 1 here and why are we doing 0? Well, for this first loop, what we're doing is we're iterating through the array, right? And in this loop, we're iterating for the size of the element, right? So if the element is 5, we want to check 1, 2, 3, 4, 5. We don't want to check 0 because we know that anything divided by 0 equals 0. It doesn't work. So there's no point checking. Yep, I think that's correct. Oh, yep. What's next? Check if the second array's element mod wait. No, we don't actually want this, do we? We don't want to modify itself. No, we want to modify this, I think. Is it? Yeah, I don't think we actually want to mod by the element. We just want to mod by the counter. So what is it again? It's an if. So if what is it? B at position I mod J is equal to 0. Factors dot push J. I think that's what we want so far. So just as a quick test, console.log factors. Let's see what we get. Okay, sweet. So we have 1, 2, 4, 8, 1, 2, 4, 8, 16, 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48. I think that is correct. Am I missing something? No, I think that's right. So how many common factors are there so far? Well, we can definitely delete the 48, the 32, the 24. So 16 occurs once, twice. So we don't want 16. About 12 only occurs once. 8, 1, 2, 3. Right, so that's 1. 6 only occurs once, so we get rid of that. 1, 2, 3. So that's 2, and then 3, I think. 1, 2, 3, and then so far there's 4 here. Okay. Yeah, but it's looking okay so far. What's next? remove the uncommon factors. So how are we doing this? Oh, we're checking the count of each factor, right? So let factors. So we're basically just doing the same thing I did just a moment ago, counting it out. But we're going to we're gonna do it programmatically now. So let common factors is equal to an array, and then loop for the size of the factors array, and then loop again. Okay. So for let I is equal to 0, while I is less than factors dot length I plus plus. Same thing. For let I is equal to 0. Well, sorry, j is equal to, is it 0? Yeah. While j is less than factors dot length j plus plus. Okay. We want a counter, I think. Yep. So let count equal to 0, and then what? So if the array element is equal to the other array elements, increment the count. So if factors at position I is equal to factors at position j, what the? Count plus plus, and then at the end of this for loop, I'm pretty sure it's if count is equal to how many times does it need to occur? Second array. So x is a factor of all the elements in the second array. Yep. So second array b dot length. Common factors dot push. Was it I or j? It doesn't really matter, I guess. But it's still going to lead to the duplicate. So if we console.log out common factors, we should only have the common factors in there, which are 4 elements. It was the 1, 2, 4, and 8, I think it was. But we should get them 3 times, so 4 by 3 is 12. We should have 12 elements in there. What? I got a 0. That's funny. What's happening here? Oh, right. We what is it? Oh no, we don't want to push. Okay, yeah, this is my mistake. We don't want to push the counter. We want to push the actual element. So factors at position I. Right. There we go. That looks a lot better. 1, 2, 3, 4. Sorry, 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Yeah, exactly. So that's how many elements? That's 4, 8, 12. Perfect. That's exactly what we want. Now, what we want to do, I think, is remove the duplicates. Yep. So this is how we did it. So it was, yeah, okay, it's the same thing. Let unique factors equal the spread operator, new set common factors. I think that's how you do it. So we console.log out unique factors. We should only get 4 elements. Yep, that is perfect. I don't know why there's a space. I don't know if that's just if that's an array thing or a string thing. It shouldn't matter. Sweet. Well, actually, maybe it's this. No, I think it's just a formatting thing. Alright, so now that we have our unique shared factors recorded, what is the next step? Check if the elements in the first. Okay, yeah, this was the modding thing, right? This one's easy. This one's fun. You know, I learned mod ages ago, like first year uni. So I love mod. I'm confident with it. I love it. So we went shared factors. This. What is next? Loop for elements in the unique array. So for let I is equal to 0, while I is less than unique factors dot length I plus plus. Right. We want to count and then loop the elements in the first array. So let count is equal to 0, and then for let j is equal to 0, while j is less than a. Oh, I missed my semicolon. While j is less than a dot length j plus plus. Wait. So I think just off the top of my head, the thing that we need to check for here is if the mod is 0. So if was it? It's how much in the first array are all factors of x. So if unique array unique factors at position I mod a at position j is equal to 0, count plus plus. Is that correct? Factors array, yep. J, right. So we just want to make sure that it's occurring 3 times. That's right, we're counting it. And then at the end of the for loop, just before it ends here, if count is equal to a dot length, shared factors is equal to shared factors of push. What is it? What are we pushing? Unique factors at position I. Okay, so now again we should only now have the factors that fit into the elements of the first array. Oh wait, I need a console log. What did I do here? Unique factors, not shared factors. Wait, no, it is unique factors. What did I do wrong? Shared factors output. No. And I forgot to console log out shared factors. Am I duplicating variables? Nope. Whew, let's have a look. No, this is not what did I do wrong? Oh wait, no, I think I'm doing two console logs. Yeah, that's why I can't. There we go. I think there's a mistake though. Sure. The final thing that we need to do is return the length, but I still think it's pretty wrong. Return shared factors dot length. Yeah. So we're missing a factor somewhere. Oh wait, here. Oh, okay. Is 1 less than 16? Yes. Is 2 less than 16? Is 15 less than 16? Yes. Is 16 less than 16? No. Right. So that's why. It needs this here. Or I can do a +1 there. Okay, I can do that. No! What did I do wrong? Oh, wrong one. This one. Okay. Yeah. Let's oh. Don't want this anymore. I think this is all done. Let's submit it and see how we go. Right, sweet. So yeah, it's definitely like a little bit of a funny challenge, but again, you know, just like if you don't understand it, you know, just try to work through it in English, because when I worked through it the first time, I just did a bunch of these. I actually just, you know, worked through the example here, and tried it myself. I did every little thing. I found, oh, so these are the common factors. Okay, so these are potentials. Does which one of these fits into the first element? Oh, it's only one, so I return one. It's definitely a little bit funny figuring it out, but you know, just stick to it, persevere. There are different ways of solving it. However, this is the most straightforward approach without using any sort of weird maths. But nonetheless, I hope you enjoyed it. I hope you learned something. You know, keep coding, stick with it. We'll all make it. I'll see you in the next video. Enjoy yourselves until then.